problem 6 of the target round, we are going to, the problem says, the hour and the minute hands of a clock create a 60-degree angle at 2 o'clock. So let's draw that out. So you have your clock here, and then you know the minute hands at 0, and the hour hands at 2 o'clock. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So the hour and the minute hand are creating a 60-degree angle. So that angle is 60 degrees at 2 o'clock. So how many seconds later is the next time when the hour and the minute hands will create a 60-degree angle? And asks us to express our answer to the nearest whole number. All right. So to do that, since we know that the minute hand right here is moving faster than the hour hand, we know that to create another 60-degree angle, the minute hand is going to have to pass the hour hand and create another 60-degree angle somewhere on the other side. So somewhere like there, right? Okay. So to do that, the first thing we're going to want to do is to find the speed in degrees per second of the hour and minute hand. So for the minute hand, we know that every hour it goes 360 degrees around the entire clock, right? So that means that it would go 360 degrees per hour. But that's not good enough. We want to find it in degrees per second because our answer up here is going to be in seconds, all right? So first we're going to divide that by 60 to get 6 degrees per minute. All right. Now we're going to divide that again to get 1/10 of a degree per second. All right. Not per 8. 1/10 of a degree per second. Right. Okay. So now we can go ahead and get rid of all of that, except for the fact that knowing that the minute hand is moving 1/10 of a degree per second right there. So then we're going to want to find that same measurement for the hour hand. So we know that every hour, the hour hand moves 30 degrees. Well, you say, how do we know that? Well, if the hour hand's at 2 o'clock and it's creating a 60-degree angle with nothing, which is the minute hand right there, that means that it moves 30 degrees per hour, right? So 30 degrees per hour. And then we're going to want to move that and divide it by 60 to get 1/2 of a degree per minute, divided by 60 again, 1/120 degrees per second, all right? And I wrote 8 again because I'm very good at this, all right? So now we're going to go ahead and erase all that work again. Just remember right here that, that the hour hand moves 1/120 degrees per second. Okay, so next, since we know that the minute hand is going to have to pass by the hour hand in order to create another 60-degree angle, we know that we want the minute hand to close this gap right here with the hour hand and then go 60 degrees farther on the other side of the hour hand. Now, that would be simple if the hour hand didn't move, but the hour hand does move, so we have to take into account the fact that the hour hand does move. We're going to say, how are we going to do that? Well, we want to find the rate of the minute hand relative to the rate of the hour hand. So to do that, because they're both moving in the same direction, all we have to do is subtract these two rates. All right, we just have to subtract those two rates. So let's do that. We say 1/10 degrees per second, or to get the common denominator, 12/120 degrees per second minus 1/120 degrees per second. All right, and so that's going to get you 11/120 degrees per second. That is the rate of the minute hand relative to the rate of the hour hand. All right. So after that, since we know the relative rate of the minute hand to the hour hand, all we have to find is how long it's going to take that minute hand to travel 120 degrees at that speed, because we know it wants to close the 60-degree gap and then open another 60-degree gap on the other side, all right? So to do that, all we have to do, so 60 plus 60, right, the closed gap plus the gap we're opening is 120. And then we have to divide that by 11 over 120, right? And you'll say, well, why are we doing that? So we know that rate times time equals distance, right? And so here we have the rate, that's this right here. We also have the distance, that's just right here, but we want to find the time. So if we want to find the time, we have to isolate t, or time, in this formula. To do that, we're going to divide both sides of this formula by r, all right? So divide both sides by r. And then we're going to get that t is equal to d over r. And that's the formula we have right over here. This is the distance, d, and this is the rate, r. All right? So now if we open up our calculator and we do that math, well, one thing we know also is that dividing by a fraction is the same as multiplying by that fraction's inverse. All right? Reciprocal. Thanks, Grady. So to do that, well, we're going to say that's 120 times 120 times 1 over 11, right? We're just splitting up that fraction of 120 over 11, right? So we're going to say that 120 divided by 11 over 120 is the same as 120 times 120 over 11, right? And so now we know we can also split that fraction of 120 over 11 up and say it's equal to 120 times 120 times 1 over 11. All right? So let's do that. 120 times 120, not times 20, 120 times 120 is equal to 14,400. Then we have to divide that number by 11, which is the same as multiplying it by 1 over 11 to get this number. And again, if we remember, this is the number of seconds it's going to take to create that second 60-degree angle. All right? But here it asks us to express our answer to the nearest whole number. So, well, the nearest whole number of this 1309.09091, right, that's just going to be 1309. All right, so the answer right here is 1309.